Hello students, myself Professor Umesh Kantela from Department of Physics. In this video, I will discuss the basic things, that is mechanical force, mechanical work done and mechanical power. So let us begin. Mechanical force has a formula. It is the mass of the body and acceleration acting on that body. Okay. So force is a vector quantity, mass is a scalar quantity, and acceleration is the vector quantity. So mechanical force has a formula, force F is M into A. Now to calculate the work done, I'll take the simple example. Consider a block of mass small m. This is the block of mass small m, whose center of mass is this, on which a force is applied. Okay. So this is the force vector and displacement of this block in the direction of force. So this is displacement vector. Now the angle between force vector and displacement vector is 0 degree because the direction of force and displacement are the same and they are acting along the same line of action. Now to calculate the work done, we know the formula. Work is product of force acting on a body into displacement of the body. Okay. So we can write work W is dot product of force F vector or scalar product and displacement S vector. Now we can write force F, displacement S and cosine angle theta in scalar form. Okay. So work is a scalar because it's a dot product or scalar product of two vectors. Now, according to this diagram, theta is 0 degree. So we can calculate the work done here. F as cos of 0 degree and cos 0 is 1. So work is force into displacement. Here, the work is positive. Okay. Work is positive and maximum also. Okay. Let us take the next case. Suppose case number 1. In this case, we will discuss the zero work done. Okay. When work would be 0? So zero work done case we have discussed. Okay. In case of zero work done, the angle theta must be 90 degree between force vector and displacement vector. So I'll draw the diagram here for better clarity. The block of mass M, whose center of mass is this. Now, according to the condition, displacement is acting in this direction and force will make an angle 90 degree with the displacement. So it is in upward direction, which makes an angle of 90 degree with the displacement vector. Okay, so this is angle theta, which is equal to 90 degree. Angle between displacement vector S and force vector F. So we have to calculate here work done. So work is force into displacement and cosine angle theta between force vector and displacement vector. So theta is 90 degree. Therefore, Fs cos of 90 degree. Now we know that cos 90 is 0. So therefore, 0 into force into displacement, that is 0. So this is the case of 0 work done. Okay, understood? Now we will see the case of negative work done. So case number second, negative work done. When work done should be negative. So stay focused. When theta is greater than 90 but less than 180. This is the case. So theta must be greater than 90 degree but less than 180 degree. In this case, the work done should be negative. So I'll draw the diagram. So you will get the idea. Same block system is here. So that block whose center of mass is this. Now, for better understanding, I'll draw the horizontal line which is passing through the center of mass or center of gravity, and which is vertical line to, okay. Now, this is the direction of displacement vector S through center of mass or center of gravity. Now, we have to apply this condition. Theta is greater than 90. So from displacement vector, this line is 90 degree and this is 180. So theta is in between 90 to 180. So force must be in between these two lines. That is in second quadrant. So this is the action line of force. Now this angle from displacement vector to force vector, that is greater than 90 but less than 180. Now what happens? See, if this is total angle, see up to this is 90. So whole angle is theta. This whole angle is theta. Okay. Whole angle is theta, which is greater than 90 and less than 180. Okay. Now this is 180 line and up to this is theta. So this remaining angle is 180 minus theta. Okay. This is 180 minus theta. Now, in between these two, angle is 180 minus theta. Force vector and this is displacement vector. Okay. So according to the work done, it is a product of force, displacement, cosine angle, theta. So work is equal to force into displacement and cos of, okay, just pay attention here. Cos of 180 minus theta. So cos 180 minus theta is minus cos theta. So therefore, force into displacement into minus cos theta. So therefore, work done is minus Fs cos theta. So in this case, the work done is negative. Okay. Now we have to observe the formulas for power. So basically, the formula for power is the ratio of work done by body in time taken. So power is work upon time. In notations, power P is work capital W upon time small t. Now we know the formula for work is F dot S upon time t. Now, the ratio of displacement upon time is velocity. So, power has one more formula, F dot V. V is the velocity of that object. Okay. So, in this video, we have seen mechanical force, work done, types of work done, and power. So, thank you very much for watching my video.